Hi, well, welcome. We're going to take a look at the shapes and how the molecules in the substance go together and see how that affects the properties of the substance in this particular videos. First of all, the shape and the size of the molecules makes a difference in the properties. For example, if we compare small molecules, something like a methane, which has only a single carbon atom plus the hydrogens that go around it. We're not going to put the hydrogens on this. If we compare it to a longer chain molecule, like maybe a hexane, we're going to find that the smaller molecules have lower melting points. So they'll turn from a solid to a liquid at a much lower temperature than a longer molecule. And this has to do with the attractive forces between the molecules, the way that they hold on to each other due to the electrons that are within them. In addition, when you get to long molecules like this and much longer molecules, we find that they allow for some stretching. So you get something like a nylon, which can stretch and go back as they hold on to each other. We saw that with the slime. And then we also have one of the other properties you tend to find with long molecules is these molecules are able to slide by each other and make a good lubricant. So you get the oils that will be liquid at room temperature. You have these long molecules slide by each other, and that allows you to use it to reduce friction in various uses. The other thing we want to look at is how the molecules hold on to each other, what kind of structure they form. For example, we can take these water molecules, hydrogen, 2 hydrogens, 1 oxygen, H2O, and when we look at how water molecules come together, they form a crystalline structure, and it has to do with the way that they line up when they become a solid. We'll take a look at that a little bit later. But what the things about substances that are crystalline solids is that they have a distinct melting point. That means they stay solid, stay solid, stay solid. As you heat them up, they stay solid, and then they hit a certain point, and then the energy begins to move the molecules apart from each other, and then it becomes a liquid. So at 0 degrees Celsius, 32 degrees Fahrenheit, the ice melts. Okay? It has a distinct melting point. It's solid before that, liquid after that. On the other hand, you get something like an amorphous solid, and the amorphous solid, the molecules, when they're in there with each other, they're just kind of randomly organized. There's no repeating pattern over a long distance. You know, you might see a pattern over a short distance, but over a long distance, they're turned one way, turned another way, turned another way. There's no pattern to it. And so we call these amorphous, without shape, amorphous solids. And these substances that are amorphous solids, which is actually most of them, they don't tend to have a distinct melting point. You get something like plastic. If you take plastic on a cold morning or out of the freezer, it tends not to fold real well. But you let it warm up and it becomes more pliable, and it gets hotter and hotter and hotter and becomes more pliable. You know, it's approaching to be more like what we associate with a liquid. And then it becomes visibly a liquid. So you have these amorphous solids that behave more and more like a liquid on the way. In fact, there's this whole other specialized knowledge we're not going to deal with this year that really considers amorphous solids to be a liquid. You know, it's the things like glass are amorphous solids. So the plastics, glasses, those are amorphous solids. Something like salt. This has a crystalline structure, and it's going to be solid until a specific point, and then after that point, it's a liquid. Okay? Ice, the same thing. I don't have ice, but I have the water. When at a certain point, it's liquid. You get it down to 32 Fahrenheit, 0 degrees Celsius, it becomes a solid. That melting point can go in either direction. Okay? So the shape or the size of the molecule makes a difference. Bigger and longer molecules tend to have higher melting points. And then the way that the molecules are structured, put together, crystalline solids have a distinct melting point. They liquid after, solid before, whereas amorphous solids they become more and more liquid-like along the way. Okay. Take a look. The direction I have down there is to draw a diagram, so like a little picture showing how an object such as a table of glass and water can be made of molecules and atoms. So draw the object and draw it being made of molecules and atoms. That's what I want you to realize, is that as we look at all these substances, they're made of molecules and atoms, whether we talk about salt or plastic or water.